welcome back. We are going to jump right into the electromagnetic waves lesson. It's broken into two separate lessons, so this is part one, and it will be broken up into two separate lessons for class as well. So first, what exactly is an electromagnetic wave? It's made out of vibrating electric and magnetic fields that are in our environment. They are everywhere. We have fields of both electric and magnetic fields, and those being perpendicular to each other. So they're like this to each other, as you can see in the graph. That's what makes the electromagnetic wave. They're also both transverse waves, so they go up and down from the source of movement. And they do not require a medium, and they can transfer energy through a vacuum, so it can go through space. It's caused by the movement of charged particles, So the particles of both the electric and magnetic fields are being moved to create this electromagnetic wave. And an example of an electromagnetic wave is light. Okay, and we'll talk about all of the different types of electromagnetic waves. Okay. So we model it two ways. First way is the wave model. So again, they are transverse waves. It's due to a disturbance of a charged particle. That's what causes the wave to happen. And it's transverse types of wave. So it goes opposite of that disturbance. So it goes up and down if that particle is moved to the right. And again, it's made of two vibrating fields, and they are perpendicular to each other. Okay, so they're like this to each other. They're not parallel. They're not in the same direction. They are like this. So rays of light, remember light is an electromagnetic wave. They have vibrating fields of all directions. So it's not like this. It's also like this, like this, and like this. So they are in all directions. So since they're in all directions, there are things called polarizing filters, which have slits in one direction, so only light that is in that one direction. So if we just chose straight, like straight up and down, only light that's passed in that straight up and down filter can pass through. So this is what is used in polarizing sunglasses. So with non-polarized lenses, the light is going all over the place, which causes that glare. And in polarized lenses, it only shows that straight up and down or straight horizontal light, which creates less of a glare. Okay. Then there's diffraction of light. So diffraction of light, that's when light passes through a teeny tiny slit and creates alternating light and dark stripes. So that pattern right here. Remember what we talked about last lesson about diffraction. It spreads and bends, so it spreads out like water waves and bends around after it passes through an opening, which is what causes that light and dark bands, because those two waves are interfering with each other, which causes the dark band, okay, because it's not making the wavelength anymore. Okay, so this is an example. So the light is emitting, or the light bulb is emitting the light waves. It passes through this one slit, and it creates diffraction. And then when it goes through two slits, it creates two different diffraction of waves. And when those waves meet each other, it causes destructive and constructive interference, which causes that black and white slit. We could also see this with light. There are all different types of colors depending on the wavelength of light, which is what creates a rainbow. So what happens in a rainbow is that water particles, when light is hitting those water particles, it's actually bending that light, causing all of the light wavelengths to emit their colors, because it's bending in a different direction. And when we go in class to talk about this, there'll be a more in-depth video showing it. I can't really show it to you right this second, but when that happens in class, you'll get a better grip of it. Okay, so remember there are two different ways to model this. There's the wave model, which we talked about, and the particle model. So the particle model comes with the photoelectric effect. That's when high frequency light, so just a really high frequency light source, knocks electrons out of metal. So let's look at this GIF right here. The light source is turned on. It's actually kicking out electrons of the metal, which makes the charge more positive, which is why the little box right here is moving up and down. Okay, it's because the metal is becoming more positive. And what is a photon? It's just a packet of light energy. We've talked about this when we talked about photosynthesis. It's just a packet of light energy that knocks an electron free if it has enough energy in it. So more energy means more high frequency. So if a wave has high frequency, it will be able to knock an electron free. Okay. Alright, so that was all we had for this lesson. Next is part 2 of electromagnetic waves. So I hope you learned something new, and I will see you then.